This lesson looks at number sequences and being able to continue the number sequences, which are a large feature of these aptitude tests. So looking at this number sequence that we have below, 2, 4, 6, 8, 10, 12, hopefully we can see that there's a common difference of 2 between each terms, so the next term will be 14. At this point, you're probably thinking, why is this video probably 4 or 5 minutes long? Okay, because they can get a lot more complicated than this, and your exposure to the different sorts of number sequences is what will help you be able to do these quickly on the aptitude test. So, for example, we have addition sequences, like the one in the introduction. In this addition sequence, we can see that there's an addition of 3 happening for each of these terms. So to get the next term here, I'll need to add 3 to get 20. Addition is not the only way we can make a sequence. Okay, we can also do multiplication. So looking at this sequence 3, 6, 12, 24, 48, I should be able to see that I've been multiplying by 2 to get from one term to the other. So I should multiply by 2 here to get my next term of 96. We need to be careful when we're looking at sequences that we don't just make assumptions on the first 2 numbers. So for this one below, I could have looked at 2 and 4 and thought, I'm adding 2, so the next one must be 10, and that would typically be one of the multiple choice options. However, if I tested my theory with the next term, I'd see that actually 4 was added. Okay, so perhaps it wasn't an addition sequence, it was actually a multiplication sequence where we're timesing by 2 to get each successive term. You need to be careful. There are also sequences which involve square numbers. So 1, 4, 9, 16, 25, if we try to find an addition or a multiplication rule there, it won't work because these terms are 1 squared, 2 squared, 3 squared, 4 squared, and 5 squared. So the next term should be 6 squared, which is 36. Again, here's a number sequence where I can't really seem to see any pattern there. I'm time pressured, I might get stuck. Okay, but I need to think, maybe this one's close to square numbers. So if I remember my square numbers, I can see some sort of a pattern happening here, that each of these numbers is 1 more than the corresponding square number. So the next square number should be 36, so 1 more than that would be 37 to complete the sequence. If you saw this sequence in the aptitude test without having this exposure to it, it would completely throw you off. Another common sort of sequence used is an alternating sequence. So I've got this sequence here, it doesn't seem to be any pattern, it's increasing, it's decreasing all over the place. However, if I look at this every second term, I can see that they're all increasing by 1. And then the other alternate terms, I can see that those are decreasing by 2. So I need to follow those blue terms, 8, 6, 4. The next term would be 2. Again, be on the lookout for these sorts of alternating sequences, because without this knowledge, you get completely stuck and thrown off in the aptitude test. Another way we can write these sequences is using 2 terms to get the next term. So looking at this first sequence, 5, 10, 15, looks like I'm just adding 5 each time. However, when I get to these later terms, it doesn't seem to follow the same pattern. So what we can see happening is if I take 5 and add 10, I'll get 15. If I take 10 and add 15, I get 25. If I take 15 and 25, I'll get 40. So to get this next term, I should add 25 and 40 to get 65. You may remember that the same idea is used in this sequence called the Fibonacci sequence, which we see in nature all around us. Alright, back to the aptitude testing. We can also do the same thing with subtraction. So 20 minus 12 gives me the next term of 8. 12 minus 8 gives me the next term of 4. So 8 minus 4 will give me the next term of 4. So I need to be looking for that combination when we're doing these questions. Finally, we can have these scenarios where the amount added changes each time. So I go through all my tests. Is it a constant addition problem? No. Is it constant multiplication? No. Anything to do with square numbers? No. Do these two terms add or subtract to give the next term? No. Okay, so let's have a look at what happens between these terms. So here I'm adding 1, and then I'm adding 2, and then I'm adding 4, and then I'm adding 8, and then I'm adding 16. So see how the amount that I add each time is doubling. So to get this next term, I should add 32 to get 68 as that following term. So have a look at the quiz, in which you'll be able to practice identifying all these sorts of sequences and identifying the next 1 or 2 terms.